Right. So yeah, so the kind of there's some nuance here which we'll get into, but one way you can kind of think about it, this problem coming up is kind of what is happening, at the level of column in terms of modeling and perceptual input and what so forth when we kind of perceive nothing. And maybe to be a bit more concrete, maybe
I mean,
no physical surface.
okay, let's be more careful. It's not perceived, but we're actually not sensing anything, right?
Yeah,
Like we might be perceiving something, but not sensing something, like we talked about yesterday. So we're talking about no physical sensation,
sure.
right?
Yeah,
So, okay.
yeah. Um, and so, it's more common with touch because, basically anytime it's not in contact with the surface of something, arguably, it's not sensing kind of anything like a kind of edge or anything like that, a kind of morphological feature or a surface. But even with vision, you can think of examples like, looking into kind of the sky or some other void, where there's no kind of clear surface that we're perceiving. Um,
Or
and
Monty. Monty also looks a lot into the void. So
Monty looks into a
we have
void all the
this a
time.
lot.
Yeah.
Yeah.
I don't get that joke.
Well,
Well,
okay.
I
Void
mean,
just
not
sounds
so
very
much
ominous.
anymore.
Yeah.
My
But
mind.
I mean, I think we just be really specific. When a sensor patch is not receiving any sensory input, I mean,
yeah, but I
it
guess
doesn't.
I guess it might be receiving kind of color, for example. That's where I feel like maybe it's not sensing kind of a surface or a morphological
Well,
feature.
let's just go for that because my understanding is that every ganglion cell leaving the retina is a center surrounding ganglion cell. So
Yeah.
if there's uniform color on a patch of retina, my understanding is that you don't get any output. You only get an output if there's an edge of color, an edge.
So I was trying to, read about that. I I mean, I didn't go too far with it, but it seemed like because of opponency and stuff, like you would still get some baseline activity that would, because otherwise, if you're looking at this, let's say you're looking at a full wall of color, you perceive that as a color. You don't perceive that.
Right. Well, that's the mystery.
Yeah.
Right. That's the mystery. But the mystery is, well, this was a lot of it about this was written a long time ago, so I haven't read anything recently. But in the old days, people would write like, "Hey, there's no input, yet you perceive something. How is that?"
Yeah.
Say, oh,
I will kind of.
maybe
Yeah, go ahead.
even if we have some representation of that constant color, the biggest thing is that there's no location or orientation being detected. So that would mean like if we say orientation is represented in the mini columns, that would mean there's no activation there. So
Right.
well, I think this is actually a really important point. So I know it sounds weird to say, "Oh, you're looking at a blue wall. No, those columns are not getting an input." That's what people said. But if we really, the idea of the center surround receptor field, I've come to really love it. It's basically a center surround receptor field says, I'm not going to report anything unless there's some change. It can be a spatial change like a parvogranular cell, or it could be a dynamic change, but there's got to be some change. So that's that's all that I care about in the world. I love that idea, and so that's general neuroscience dogma. And so I think we should ask ourselves: do we want to pursue the idea that you might get something like pure color or not? I prefer not to.
Yeah.
I would just say, how do we explain the perception of color?
Yeah.
Without.
So I guess towards the end, I'll have some slides that kind of relate to that. So yeah. Well, that will be revisited. But yeah, so I guess for now, let's assume you also don't get color. You perceive nothing, sense nothing.
I guess it's really the question is, if it's uniform, there's no output. So
yeah.
That means you could be touching a surface. I don't know, but but it's like your finger has to be moving or something like that.
Yeah.
Yeah, I don't know. All right, let's keep going.
Also, if there's no like center surround output, I mean, we can still perceive it as okay, whatever I'm looking at is uniform or doesn't have any edge. Like I guess well, one of the question here is that even though we're not sensing anything by center surround, that still that may tell us the information that, okay, like whatever it is, it's no edge or it's a continuous
Well,
surface. So,
Well, I think Jeff's point is that, yeah, there would be no activity, but then the question is, how do you know what color it is? Like there would be no spiking, basically.
right.
well,
Yeah.
right. It has to come from the edges of the color. That's
Right.
that's the general.
But maybe there are, yeah, I feel like we can
Well,
come up with stimuli where there are no edges.
Well,
Like,
that was the example I gave with the checkerboard. Remember, with the checkerboard illusion I wrote about yesterday. So I don't have
Yeah.
right. I don't have it in front of me. But the reason that illusion works is because you see the edges of the squares, but you don't see the gradual change occurring within the square. It's gradual enough that it doesn't excite any of those ganglion cells. And so the brain, however it does it, it assumes that it's continuous across that. You don't perceive that it's actually changing from black to white. And there's a lot of examples like this in the arts and visual arts and so on, where the tricks of colors and so on. So,
Yeah.
I mean, it is kind of mysterious that you perceive that you see, like, it looks like you see this red across the entire surface of the fire truck, but it seems from the retina that's not true. It seems from the retina there's red edges at certain places, and the rest of it is just perceived. It's like crazy, but that seems to be pretty. I think that's well established science, but I don't know. It may have changed.
Oh, sorry. One more thing. Also, I know Tristan posted a question. Is that I think sometimes we like model sensors at like really at the single cell level, like okay, retinal, like center surround, or but then we had kind of a brief discussion about this, like when we were doing edge detection, is that instead of directly like implementing Gabor filters for edge detection, is that maybe this perception happens because it's retinal ganglion cells plus some other color opponency cells. So it's like, okay, no input, no output from the retinal ganglion, no output from the center surround, but some baseline in this RG, like let's say.
But baseline coming from the retina?
From color opponency.
In the
cells.
retina. I'm just saying, okay, we got axons coming out of the back of the retina. That's what we're talking about here.
Yeah.
By the way, I think they could be. Some cells have a constant activity, right? They increase or decrease. So when we say no activity, we're saying there's no change in activity.
Right.
So when you say color opponency, is that another signal coming out of the back of the retina that's not center surround?
Yes. But I'm not sure if
that might exist. I just don't know about it. I don't, who knows?
Yeah,
maybe it's there.
But yeah, the point was that like maybe there's a combination of cells that give rise to like the perception, even if that particular one.
Maybe, but why wouldn't?
I don't know.
I'm gonna get to Tristan's question in a second, but it feels to me like we should at least have the working assumption in ophthalmology and neuroscientists for many years was that all the in-between stuff is perceived but not sensed. Now that could be wrong. I don't know what the current literature states about this. Maybe they found some new cells that are just red cells or something like that. But I think we should at least work with that assumption as far as we can before we abandon it, because that was pretty well established a long time ago. Yeah. And Tristan, I don't think blinking, well, it's a good question whether blinking would activate things like that, but I don't think so. I think, when we blink, does someone else remember this? It's like the brain shuts off everything.
Yeah, I think it gates the input.
Right, but I don't think blinking, the actual turning on and off of the light to the retina is, well, the general idea is, I've never heard anyone suggest that that's somehow useful other than keeping your eyes wet.
It's a spatial gradient and not a temporal gradient.
It's just like there's mechanisms, as Vivian said, that just basically say, ignore this. don't pay any attention to this. It didn't happen.
Like saccadic suppression or something like that.
Yeah, but this is specifically for blinking, I think, right? Because otherwise, it'd be like the world would be blinking on and off all the time. So it somehow gets around that. Well, I think, look, all these are possibilities, but I don't think we should we should happily go beyond what the physiology and has suggested in the past, unless we have new evidence. So I would, throughout this whole discussion, I'm going to ask myself, well, how is it that we perceive the color when then we actually don't get any input in the middle? But we do get it at the edges. So that's, I mean, that's a really interesting question. You know, it's like, okay, there's all kinds of weird questions come out of that, or ideas come out of that. But
Yeah,
anyway.
no, yeah, interesting question about the blinking. I just thought this might be a helpful example as well. So this is an illusion where it's definitely you're perceiving what is not sensed, because we perceive a kind of blue circle, but in reality this is pure white, and so
Yeah.
it's just because of these edges that you kind of fill it in.
You can almost see you really sort of perceive the blue edge between the two circles, you know, between the circles.
Yeah, right.
Right
Yeah,
there,
yeah,
right,
yeah. It
right.
feels like there's an edge there.
It feels
But
like
if
it's
you
there.
yeah, it's maddening. But then if you cover up the screen, you can convince yourself that yeah, it's all in the head.
So I think that's a really strong indication that clearly whatever cells are reading that area are not getting any blue, and
Yeah.
yet you're perceiving it.
But I guess what I would argue there, the perception is subtle. It's there, but it's do you know what I mean? It's not as vivid as when you actually see the red of a fire truck or whatever. It feels different somehow.
Well, right, because
so-
you actually don't have those the blue edge detector cells there, right?
But I guess they're active on the edge. I don't know. Yeah.
Well, all right. I think it's an interesting artifact. Like, you know, it's like what you're saying is, imagine I see a red truck. And then I say, well, if the center was not red, I would notice it. Yeah, but then I'd have an edge where it goes from red to white or something like that. So
right. Yeah, so it's kind of impossible to set up almost the control experiment. That's
kind of.
Yeah.
Although, you know, if you do look at if you can really isolate yourself and look at a pure color, like all you can see, over time that color disappears. You're not even sure what color you're looking at anymore. So, like, you know, I forget the context of this experiment, but you can do this where all of a sudden, you know, your entire environment turns red. You perceive red, but changed. That was important. It changed from non-red to red. But then over time, you kind of forget. You don't really know what color it is anymore. It just sort of.
I mean, it kind of happens, I think, just when you close your eyes. If you're kind of not sleeping and you focus on your visual field when you close your eyes, you start seeing colored patches that kind of move and oscillate. And,
right. Well, that's a different
yeah.
problem, but you're right. Anyway, so it's not clear. I mean, I think that example, that little illusion you showed was a very clear example. Also, there's a thing called the one where they show with the little Pac-Man with a triangle.
Yeah,
you know.
the Kazina triangle, I think it's called.
Yeah.
Kaniza triangle. And
there too, you perceive the edge. It looks like you're seeing an edge there, but you're not. It's like incredible. It's like, yeah, you perceive. So here we have an example where you're perceiving an edge when there wasn't one. And then with the checkerboard, we have examples where there is a transition from black to white and you don't even perceive it.
Right. Just for anyone who hasn't seen it before, it's this illusory triangle that appears to kind of be floating. That's the illusion.
Yeah. And you kind of, it's
triangles, even though there are no triangles in the picture.
That's true. But you don't perceive the one in the background. You don't perceive the edge. You assume it's occluded, and but you actually almost like you're sensing the edge of the white triangle, which it doesn't exist. You kind of feel it's the same as the previous illustration. Yeah, this is this example, where
so here the illusion again. Most people probably know it, but in case you don't, the kind of counterintuitive truth is that A and B are the same color, the same grayscale value, but of course B looks like it's white.
Right.
But I guess this one, it's not just the I don't think it's just the like gradual change. It is also playing on kind of like higher level
No, you know what?
object perception with the shadow and stuff.
But I think either in my book or somewhere I showed that that's not true. You can take
Oh,
the
really?
actual,
If you cover it
you
up.
can, you take, this is not the exact image I started with, which was not a green cup, it was a cylinder. But you can remove that and you still, I can maybe try to find the image I have. You can remove that
Interesting.
and so you don't know there's a shadow.
Yeah, but you still
perceive
think they're
it.
the same.
Right.
Oh, sorry, you still think they're different rather.
Right. And you think they're different. It's so I've narrowed it. I took these images and I edited them so there's just a little like skinny rectangles that go across the A and the B, and
Yeah.
across there. And I really tried to figure out what the hell's going on here. How does this work, right? So you can
Right.
remove all this extraneous stuff. You can get rid of the fact that it's a checkerboard, and I kind of concluded, I could be wrong, but I concluded in the end that I got down to this example where it's basically a gradient between edges, and you just don't perceive the gradient. Now this has got a lot going on in this picture. So what I did, and this has also got a 3D perspective to it, all this stuff. So I kind of isolated it down to a very simple version of this, and it was still very strong. And I think the only explanation there was, that in a sense that shadow is almost it makes you feel like there's a higher order effect going on here, but it's not really true. I got rid of it, and it still works.
Okay, yeah.
Yeah. So anyway.
So if
Cool. Well,
if we
yeah.
only have, if we can only detect the changes in colors, how are gradient, like slow changing gradients, detected in models and modeled? Like, what would happen if the fire truck would have a gradient towards the middle that slowly changes from red to white, but there's no clear edge?
Yeah.
Is
Well,
that
that's
just
kind
like
of
the receptive field size? Some receptive fields are large with low resolution, and for them it is a gradient.
and it's an interesting question. It's like it's very similar to the little checkerboard we just showed there. I'm wondering if I got rid of the idea that there was a cylinder and a shadow, but it didn't get rid of the idea that there were very clear edges in a regular pattern going across here, like sort of like a checkerboard. Where if you don't have that, like if you just have like a fire truck,
But yeah, basically you're saying, Vivian, like, how do we perceive this, or like, how is this modeled?
Yeah.
If this essentially cannot drive activity.
Well,
supposedly.
this sounds really crazy, but one possibility is, and it's hard to believe this, but this is what it suggests. Imagine you really only are detecting the edges, right? And those edges are different.
Right, and this is all in your mind.
Well, yeah. I mean, obviously, if the gradient's strong enough, it would trigger a center surround cell. But if it's very weak,
But what about like when there are no edges, like the sunset, for example?
well, that's my point. When you get rid of the edges, then that's like being in a total green environment. All of a sudden, you start losing your color abilities. It just doesn't. It doesn't. You're not even sure what color it is anymore. If everything is the same color, it's just like you lose the ability to tell if it's brighter or not. It's just, these are all relative. The basic theory, which is hard to believe, but it seems to be a lot of evidence, is that everything is relative. So if you don't have a relative change anywhere, you don't perceive it. So obviously in those pictures there, we had a gradient. If the gradient is sharp enough, well, then you might perceive it. But if the gradient is gradual enough, you wouldn't. So a sunset, there's always an edge, right? It's someplace. You got clouds, you got the horizon. I don't know. You got the building. I don't know what it is. You got edges someplace. It's hard to see a sunset without any features. I bet you people have studied this.
Somebody
has
I'm sure
studied
we
this.
can find something on it. But yeah, that was a good, I guess, a good primer on illusions and perception of color. I think it'll help with the discussion later. As I said, I've got some stuff on this kind of filling in effect. if we did want to explore it in Monty. Do you see my slides?
Yeah.
Okay. Yeah, so there's a couple of situations that can arise, but you can imagine we have a mug in habitat that Monty's perceiving. It has a bunch of hypotheses about where it might be. This is where the sensor actually is, and this is where the sensor is going to move. And this happens to be one of the hypotheses.
I'm
And
saying
so
one and two are where it actually is. Oh, green,
1 and 2
green,
in red.
green is the, oh no, red is, I see, red is.
Yeah, red is actual, and green is a hypothesized location.
Okay.
So moves from 1 to 2. So in this example, this hypothesis thinks it stayed within the mug, but it actually moved off and is sensing nothing. Either it's kind of looking into the far distance, or it's the finger and it's not sensing anything. And this was kind of the first situation that sort of got us thinking about this problem. Because right now what happens in Monty is we kind of, Monty, for lack of a better word, kind of panics and then goes back on the object and kind of forgets about the fact that it saw nothing, that it stared into the void.
Well,
And
it actually doesn't send that to the learning module.
That's what I was going to say. Yeah, so it moves back onto the object, and that information is not sent to the learning module.
Well, does it update its hypothesis? Does it update its hypothesis?
No.
Oh, well, that would be a mistake. I mean, it seems like something ought to happen.
Yeah, so this hypothesis seems clearly wrong. And so it makes sense to kind of process this as a prediction error. So you perceived nothing, but you expected something, and to have negative evidence. And so this seems like a straightforward change, and so that's why we kind of planned on doing it. But then, there's just kind of some kind of edge cases or situations that arise that make it a little more complicated than that. One of those is we can also have, in this context, what we call
can I stop you for a second?
Yeah,
when we say we have an hypothesized location, that's a location on a specific object, right?
Yeah, so this is within the reference frame of the mug.
So you know what? This is weird. Lately, we've been talking about the idea that attention has to do with some volume in space.
Yeah.
And in some way, when I see that sensor moving from 1 to 2, does it think it's on the right side of the mug, or is it? I mean, the hypothesis. Oh, I'm sorry. The hypothesized location is it thinks it's on the left side of the mug, so it thinks it's still sticking within the reference. It says I'm still within the mug. Okay,
so it's going to predict. It's going to predict. Oh, you're going to sense surface. You're going to sense smooth ceramic, whatever. But actually, it gets nothing.
Okay. Well, that would. Okay. All right. Sorry.
So that's where we're saying. Okay, that seems pretty clear. Okay, it should be a prediction error.
Right.
No, that's okay.
Keep going.
It should be a prediction error. This hypothesis isn't a good one because it's not. So we should get rid of it.
Right.
But then, in this context as well as other contexts, you could get what we've started calling an out of reference frame movement. So imagine the hypothesis thinks it's here, and whatever movement it takes place, you can imagine it goes off the object, ends up moving it out here. And in this case, it's actually moved beyond the learned reference frame. Imagine the learned reference frame is kind of a point cloud corresponding to the muck. So it's beyond anything it's learned before, or kind of knows about the object.
How's this different than the previous case?
Well, in some sense, if it senses nothing, then this hypothesis is actually correct. It could be correct. It could be that the sensor actually was here, and it moved off the object.
So why would it go outside of the volume of the object? Well, what if the system as a whole knew where the object was? Then it would know in advance that this would be moving off the object.
What if the system as a whole knew where the object is?
Right. If I could look down and say, okay, I know where I am in this mug. I know where the volume. This particular it could know in advance that it's moving outside of the bounds of the mug. What if it just knew in advance?
Yeah, I think that's the hypothesis here. Like what Monty thinks is actually correct. So it's correctly predicting that it should be off the object now.
Yeah. So what is the problem there? At that point, this column shouldn't be participating in voting.
Oh yeah, or in kind of perception. Exactly. So if this hypothesis is kind of correct, yeah, exactly that. It shouldn't kind of maintain, or certainly it shouldn't kind of pass up the hierarchy, mug at XYZ, because there is no mug at XYZ.
Right. So
So
the way I've been thinking
this hypothesis was kind of correct, but it's no longer relevant after this movement.
Right. Remember, we've been moving towards this idea that there's like a tension in a body-centric space. And all the columns know that whether they're attending within that space or not, right?
Yeah.
It just assumed that they knew this. So, and only the ones in that space get the vote. So if you're outside of the space, you don't get the vote. But if you're inside of the space, you get the vote. And that's the gating factor.
But so this column is attending to that space. It's just it's not sensing anything there.
But it's outside of the volume of the object.
Yeah, this one. Yeah.
Right. So at this point, it'd be like, imagine I'm moving my retina around and I'm looking at different parts of this cup. Well, there are many, many columns that are not on the cup, right? And columns that are on the cup when I'm looking on the left side of the cup, they will be off the cup when I'm looking on the right side and vice versa, right? So there's tons of columns that are going in and out of the actual object all the time. And the way I've been thinking about this recently is that there's a sort of a global attentional volume of some sense, and every column, it's either in that volume or outside of that volume. If it's in that volume, it's part of the inference process. If it's outside the volume, it shouldn't. And the way you might enforce that is this by some sort of voting. Like, you don't get the vote if you're outside of the column. You can get an input. I don't care, but you don't get the vote. Your input doesn't make any difference to me. We're only attending to this spot and this area.
But that spot is in body-centric coordinates. I mean, I agree that we should restrict voting based on that. But to me, that feels separate from this particular hypothesis being inside or outside of the reference frame.
Well, but you said yourself, does it pass up the hierarchy? No, it doesn't. If it doesn't vote, right. if that column says I'm out of bounds, I don't get my vote doesn't count, then it doesn't go anywhere. It doesn't affect anybody. Nobody.
Right.
You could just scream in the wind all you want. Doesn't matter. You're not part of this team right now. You're outside of the boundary. So I just think, like, when we think about what happens in this case, I haven't let you get to that point yet. But as soon as you said the word, like, oh, does it go up the hierarchy or not? I'm thinking, like, no, it shouldn't. This is all recent thinking, Niels.
So would you say?
Yeah.
Would you say it's still like it doesn't output anything to up the hierarchy or for voting, but would you say it still gets sensory input and still maintains the Mark hypothesis, so that if you move back,
I don't know. We don't know since we haven't proposed yet a mechanism for this sort of global attention space, right? Does it gate input coming from the thalamus and says you don't get to pass your input through? I don't know. Is it?
Yeah, because in this case, isn't this, let's say the fovea is here, and then now the fovea is here. So I don't, like in this case, I don't see why you would gate before the column has even received anything. It feels like it's more the column's decision based on its hypotheses to say, okay, I'm not sharing this because I'm out of any relevant reference frames.
But why would it be that a column? The idea of a global attention space.
Yeah.
Is not just global. It can't be at the local to the column. A column wouldn't know that. A column knows where it is. A column has a point in that space. But we haven't proposed a mechanism for this. But it seems to me it has to be somewhat extra column outside of the column to decide.
Yeah, basically, I'm saying that there can be multiple kinds of gating or deciding whether to pass information. But if it's the global attention, that's basically saying, like, okay, all these columns, you get to perceive stuff, and after the next saccade, all the columns here get to perceive stuff.
No, they wouldn't, because they'd be outside of the attended space. You don't.
But why if we've saccaded here, why would we be attending here still?
Attending is not where.
I mean, we could do what do you call it? Yeah, like what's that term for when you attend separate to where you're fixating? But
right. It's now I can't.
But that's obviously unusual. Like, yeah.
Well, it's doable, but it's not really that unusual. It actually happens all the time.
But just for the sake of argument, if we just say that we're attending to the same location that we're fixating,
no,
it just feels like a separate issue from this out of reference frame movement.
I don't see it is. Attention is separate from fixating. It's just a term for where the center of the retina is pointing, right? That's the fixation point, right? But the columns are covering the entire visual space, different resolutions. And so I think fixation often involves, we often fixate within the attended region, but not always, but it's generally a good idea because you have higher resolution for doing that. But I think, the example I've given a lot is, if something unexpected happens off to your side or behind you, you'll attend to that space before you can even move there, before you can move to your, or you'll try to, it'll be like covert attention. Something flashes over there.
Thank you. That's the word.
Yeah, Vivian came up with it. I couldn't remember it either. This covert attention, I think the basic idea is that you immediately start attending to it. It's a very fast reaction, and then it takes a bit of time for the eyes and the head to move and all that kind of stuff. So you'll start attending that space, trying to perceive what it is before you actually fixate on it, if it's possible. But anyway, I have this vision, like you got this point in some location in this global body-centric space, and at any point in time, all the different sensory columns are either in that space or not in that space. They're either attending there or not attending there. And whoever is attending there gets to participate, and it could be low resolution stuff initially, but then you'll try to move the high resolution stuff into that space. So in this case, if I moved my fovea from the 1 to the 2 location, I'm not sure why I did that. Normally, that would be the reason you would do that is because you wanted to attend to something besides the bug. That's why you would do it. Something.
Yeah, maybe it'll be clear with another example I have in a minute, a bit more. Yeah, maybe I'll just continue, but because I think, anyways. Like I think both these mechanisms are relevant. I guess I'm just trying to say I don't think it's the same thing.
What both mechanisms? What two mechanisms?
A learning module keeping track of a hypothesis that moves out of reference frame, and a global attentional window that gates what columns are receiving information. Like those would both take part in determining how information flows when this movement takes place, but I feel like they're different things.
Well, maybe we shouldn't spend more time on it if you don't want it, but it does seem like they're different things. But I do feel like it's like, for example,
I agree. Yeah, I agree. Like when you move your eye, like that global attention is definitely going to change, and that is definitely going to affect which columns, I guess, are getting information.
No, I think the global attention is independent of where the columns are pointing. There's an attended volume of space.
Sure.
And a column is either in it or not in it. If a column moves out of it, it's possible. It's possible that the column moves out of it is still in the reference frame of the object, but it just doesn't get the vote. Like sure. If I haven't re-anchored my reference frames, then I'm still thinking about that object. I'm just not on it, right? But my reference frame is still anchored. And so my point is outside in that reference frame. It's outside of the egocentric reference frames. Therefore, I don't get the vote, and my input is ignored. Whether we shut it off or not, I don't know. But I'm ignored, but I could still be modeling the object. I'm just outside of. I'm in the reference frame of the object, but I'm not on the object. I think that's all consistent. And then when you attend to a new location in space, that's not the same as moving your eyes there. But this is the big change in my thinking here. It's that attending to it is not moving your eyes there. Attention is, I've now decided as a brain, we want to look at something else in the volume of the world. And now I would assume that I'm looking at a different object. So if the eye moves to 2, and if I don't change my attention, just my fixation point, then everybody's still thinking about the cup. But if I move to 2 because there's another object there, and I now have a new volume I want to attend to, then the cup is forgotten, and everyone's looking at the new thing. I know this is hard to think about, but maybe we should just go
Yeah.
through.
Yeah, maybe the next examples that Niels might bring up might have a bit, because I think maybe the point that might come up next is like sometimes it gives you information about what you're sensing. If
Yeah, it
something
has kind
doesn't
of practical
exist somewhere.
implications
Okay,
and
well,
stuff.
let's go for it then.
But yeah, but I think generally we agree on this, that yeah, even if this hypothesis was right, it's not sensing the object anymore, so it shouldn't kind of it shouldn't continue passing up in some way, kind of mug at location 2.
Right.
And really we kind of, one thing we realize is we don't need to wait for an off object. It may be that there's another object here that we sense, or maybe that we're kind of now off object, we're pointing at the sky or whatever. But we don't need to wait for that, because as soon as we've moved out of the reference frame, we know we're not on this object anymore.
Just one last thing. Do we still increment the evidence of a hypothesis that correctly predicts that's in the void now? Because it might come back onto the object later. And
yeah, so this is the question of how to best handle this, which I'll get to. At the moment, I mean, it's the same as before. If it went off into the void, it would just move back onto the object, and nothing would happen to the evidence value. But this is where we did some experiments where we thought we could prune hypotheses quickly by, if we have this out of reference frame movement, we get rid of that hypothesis. I now think that's maybe a mistake. I mean, anyways, we found, at least with a small spatial filter, that kind of made us susceptible to noise, because basically if we were slightly off of the reference frame, we would kind of discard hypotheses and say, oh, this isn't on the object.
I mean, it seems like we shouldn't be doing anything because we didn't make a prediction. So like if we're moving out of the reference frame, the model can't predict what's going to be there. So there's no prediction. Anything could be there. There could be any other object. There could be nothing. There could be the same mug again, the same mug type again behind it. So if there's no prediction, it seems like we shouldn't be able to increment or decrement
Exactly
evidence.
You know, I want to say this again. I think we're going to have to be more precise in our use of language. And so this is new. It's not like I've been talking about this before. But when we say out of reference frame, that's a very confusing statement. There's a reference frame.
You're right. That's true. That's maybe out of model.
Right.
We moved to a location in the model that doesn't have a feature associated with it.
Right, but
that's even more confusing. I feel, isn't it, if we say the reference frame is the space and model is the learned points in the space?
I've always used the word reference frame to refer to the anchoring of grid cells. So to me, the anchoring grid cells, that reference frame covers all of the universe. It's an infinite space. Once I've anchored the grid cells, I can represent points everywhere. It's independent of the area occupied by the model. And so that is like the attended area, or the attended area is also the model's area. So I wouldn't say, to me, is if I say out of reference frame, it doesn't make any sense. It's like either I change my reference frame to something else, I have a new hypothesis of what the object is, or I'm in the reference frame, I'm just out of the expected attended area of the object. I'm out of the area that's generally occupied by the object, which is the attended area, in this case, if I know the object. We haven't talked about how to do any of that stuff, but out of model movement, right. It's still in the reference frame of the object. It's just out of the model's known features. Space. Right, or its features, where the features are known to exist.
Yeah.
Which is also represented globally somehow,
Right. Yeah, no, that's a clear what you call it.
Yeah. But we're gonna have to practice this because we've been using the language sloppily in just not poorly, but now we understand it has to be
Right.
more precise. Okay,
Um,
a practical problem.
yeah, and so there's a practical problem. Vivian first came across this when someone was working on MNIST, and trying to get that working. And basically, there's this issue of distinguishing a 1 versus a 7. But I'm going to use what I think is an even kind of clearer example of an eye versus a vertical bar. And you're trying to distinguish these. So assuming you've learned models for both, you have an eye model and a vertical bar model. And now you have this visual field where you're going to see a small part of the world at any given time. You're going to saccade around. Okay, and now you need to predict what you're going to see up here. And
we don't know yet, right? Because
yeah, you don't know yet.
You have two hypotheses at this point.
Yeah, you have two hypotheses at this point. You have equal evidence for both of them. They're both equally valid. And you move to that location. Now you see there was nothing. So then the question is, okay, how should we handle this internally? Because the way Monty would currently work is it would basically move back onto the vertical bar because it was a vertical bar. And it wouldn't update its evidence, and it wouldn't kind of be able to deal with this. If we so when a natural thing to do is
we don't get input, like we don't send the observation to the learning module
right.
if there was no feature in there, if there was nothing in that field.
Right. So yeah, a natural thing to do is pass this kind of off object observation. That basically, so this is the model that moved here, and it predicted something because it has these points in the model that's not consistent with kind of a null or absent morphological feature. And so this hypothesis should receive strong negative evidence. That was the kind of simple example we had before.
It's not there.
If it's not there.
If the dot's not there, yeah. Right.
The vertical bar is a bit trickier because, yeah, we initially thought, okay, well, this is an out of reference frame movement. So in the past, we've discussed kind of actually reducing evidence for that object because we're moving off of it. But you could all like the polar opposite is you could say, is this actually evidence for the vertical bar, given it correctly predicted and there was nothing there?
No, I would think not.
Right, and that I would agree, which is good. So, what I think we've kind of converged on, it sounds like at least, is that if the hypothesis goes quiet for some time, but does not receive negative evidence, then so because the issue is if we move, we need some way to actually build confidence that this is the bar, the vertical bar. But if that goes quiet until we move back onto the object, and since the other hypotheses that predicted something would get negative evidence, then that should be enough to basically separate these out.
Well, I'm confused about the mechanism here. It seems like you have two hypotheses. Those two hypotheses would have two reference frames. That is, they would have two anchorings of reference frames. Whether they're simultaneously held or oscillating between them, I don't know. But there's two different reference frames. And in one case, there's a prediction that that there should be a dot. In the other case, there's no prediction should be a dot. So in some sense, I don't know how you do this, but as soon as you test, you could put the mechanisms aside. You could differentiate between the two hypotheses by in the object model for the dot for the dotted bar, then you go there and it's not there. That just sort of eliminated right away, right? I mean, it just says that can't be right. So I don't understand how this is consistent with sort of what was the term you used a moment ago on your next slide?
Okay, I mean that's what I was kind of saying. Maybe the terminology is unclear, but yeah, the out of model movement, we basically want to maintain. We're not going to add evidence to that hypothesis because it's not predicted anything, and we're outside of that model anyways. So it doesn't make sense to kind of accumulate evidence for it. But what
You
we
wouldn't, I
can
guess,
do is,
I guess
yeah.
you wouldn't move to that location. If imagine I can maintain, let's say I can maintain one hypothesis or the other. Just imagine I can say, oh, is it A or is it B? Is it A or is it B? Well, under A, I would say I should move there and see if there's something there. Under B, I wouldn't move there. I wouldn't. I'm happy.
Wouldn't you?
Yes.
Because you're trying to tell, like, if I had given you this and you're trying to distinguish which of those ones, that's the natural place to go.
Right. But imagine I have to go between these two, right? So if I'm considering hypothesis A, I would go there just because I expect it to be there. But if I'm considering hypothesis B, I don't need to
You're
go
considering both because they're
Well,
both equally
right.
likely at that
Well,
point.
there. Right.
But
But
you're
so you-
acting on one. I think that's what Jeff is trying to say. Like you went to a
Right.
hypothesis,
Thank you.
but there's like one, that's, let's say it's like leading by
Sure.
like,
Okay. I agree. It's
Yeah.
hypothesis A that's telling you the reason to go there.
right.
But it
There's
still
nothing
seems
in
like-
B that makes that point. There's nothing in this
So-
model that
so-
makes that location interesting. I agree with that.
So which is A? A's got the dot or B's got the dot? Which is
I guess we're saying A has the dot.
okay.
We could just say I.
I have not.
And vertical bar does not.
But the weird thing is, like, as soon as you go there and you see nothing, even though you're not on the bar anymore, you instantly know that you were on the bar. Because you know it's not the eye.
Well, I think, okay, this depends on what kind of models that you have like in Monty's brain. If it's just eye and vertical bar, then I think we know that's the vertical bar. But then we need to consider like every other model that exists in Monty, and we might need to give like, positive evidence for all those models. So like we're basically, if we give positive evidence, then we're increasing a discriminatory space, right? Like the difference between the
Or you
two
mean rather
evidence
negative
values.
evidence? In this case, we're only giving negative evidence.
Yeah, I mean, so negative evidence for the eye and then positive evidence for the vertical bar.
But do we want to give positive evidence for the vertical bar? I mean,
my statement is no. Like, and my position is we shouldn't, even though I know that like if we don't see anything, it is immediately vertical bar. But that's only the case for when you have eye or vertical bar only. So like in general, I don't think we should give like that positive evidence to the vertical bar.
Yeah, I think we agree on that. I guess the question is just like, I think we agree that we want to give negative evidence for the eye model because it predicted that there should be a bar, that there should be a dot, but there wasn't. And then we don't want to give positive evidence here because we're not actually on the bar anymore.
Right.
But it also seems like if we move back again, we know it's the bar and not the eye anymore.
So I guess I'm saying
Maybe that
when you're moving when you're moving between these, imagine these two hypotheses have to have two different grid cell anchorings.
yeah.
Right? They're not the same. There isn't one reference frame. So you can either be in hypothesis A or hypothesis B and each have their own reference frame. So if I'm just looking at the bar, there's no reason. The bar model's happy, right? It's a happy camper. And it doesn't, but only when I get to the eye model, then we have to switch to a different hypothesis. I guess I'm trying to think like, it's not like we're in the same reference frame and you're moving in and out of the reference frame. It's like there's different reference frames and there's different hypotheses somehow.
I think that's how we're thinking of it. But I guess maybe to give a bit more context, one thing Hoche tried a couple of months ago and we were thinking about is, well, if we move off the object and the model predicts that the object isn't there anymore, like in the case of the bar, we should just delete that hypothesis because we're not on the bar anymore.
So say this sentence again. I got lost.
So we're on the bar and
Yeah.
we move up. Our model knows the bar doesn't exist there anymore.
Well, why would I move there? The bar model wouldn't go there. The bar model
It goes there because
The
it thinks it could be the eye or
but then
this.
the bar,
And the way
at
to
that
distinguish
point,
them
at that
is
point,
to
it's
move to the
switched-
dot.
No, at that point, it's switched to the eye model. It's no longer in the bar model. It's the eye model. The new model, new reference frame. And
But I mean,
wouldn't they
haven't
both
we
be
discussed
active?
how? Yeah, haven't we discussed how like columns could within like a phase or something, they could have multiple hypotheses they're testing.
Right. I'm just pointing out that the moment you move up there, the hypothesis you're testing is the eye model, not the bar model. So I wouldn't move up there on the bar model.
Yeah,
Unless,
but we still have the bar model active. It was still a
And
hypothesis.
it's still going to get the movement that integrates to move it up.
yeah, but at that moment, the bar model is not active. It's the I model that's active.
Well, aren't they?
You
I
alternate.
agree.
You
The bar
alternate.
model doesn't give that hypothesized location to move to, but they're both going to be integrating movement to update where you are.
Right, but they're not both in. They can't. We don't know the mechanism. It could be that they're doing this union thing. We don't know. But the point is, just think of it the moment. It's like you're alternating back and forth between these things. You're either at moment you're saying it's an I, or your moment you're saying it's a bar, and it could be very rapid. It may not be conscious of this, whatever. But in the case that you're only going to move up there, if you're on the bar model, there's no reason to move up there.
Yeah, but if we were on the I model and we said, let's go up there and see if the I is there, we still have the hypothesis that we alternate with for the bar, and that space would also need to integrate that movement we just took.
But yes, but we don't know the mechanism. But fine. But I'm not on the bar model at that point in time. So
exactly.
The I model comes along and says, "This is me," and I'm good. You're saying how do I limit?
It's actually perceiving the vertical bar. So the I model is going to say, "Oh, I'm bowing out. This is not me."
Well, this is the case where it's a null up there.
Yeah. Which is the problem that we're considering.
Is the problem
it's straightforward when it's not the null and we're still on the object. That's a case we already handle.
I would think the harder part is you see the dot and how do you tell it to get rid of the bar?
No, that's straightforward. That's pretty straightforward because
that
the bar
seems to be
doesn't exist. The bar model doesn't store features there, but we get features as input, so that gets negative evidence.
But it could be the bar and then there's some noise in the background. Anyway, I think I thought that's a harder one. Why do you think what you think the hard one is what? Let's walk through exactly. There's a dot there.
There's no dot there.
Oh,
that's
okay.
The hard one, where the dot is not there.
Okay. And
for two reasons. One is we don't send that observation at all at the moment because there's no observation there. So like, I guess no sensors around cells being triggered. The second problem is even if we were sending that observation to learning module, the I model would not have a prediction of what should be there because like you said, anything could be there. It could be a textured background, there could be whatever. So it wouldn't make a prediction. So it wouldn't think that the I is there anymore because that's not where its model exists.
I still think it's easier the other way around than what you're saying.
I think in our code, what's missing from our discussion is that our movements doesn't tell us the reason, right? Like we will move up to the dot part because we think that we're acting on hypothesis I, but in code, like we don't know why we're moving, kind of like we just move there and we update all the hypotheses for all objects, I, L, A, whatever. But it sounds like what we might need to do is that, okay, like I moved because I thought I was an I. So when I do that, I'm going to update only the evidence for I. Maybe that's a terrible idea.
I mean, we do have that information. The learning module knows what's its most likely hypothesis, and that's what it tests with the movement. So, but I'm not sure if it would help to only update the most likely hypothesis at every step.
Can I?
What? Sorry.
Okay, I have a different approach. I have a different approach to think about this.
Yeah.
But I'll finish your thought with Vivian here.
I think so. We will be updating all the hypotheses associated with that object, not just the MLH, not just one hypothesis, but all the I's. So it will be if there's 100 hypotheses for every object, then we'll be updating all 100 of them, which would include the MLH.
Yeah, but what would be the benefit of not updating the other models' hypotheses? Like if we
I guess
only ever
that's
update the evidence for the most likely object, the other ones
Yeah,
are
I
not
think that's about
taking
it, yeah.
any advantage of the sensory input that we're getting.
Even Jeff, like even in the 2019 paper, like in the model, multiple hypotheses were updated in parallel, like
Right.
multiple reference frames.
Right.
And yeah, I feel like
right.
we've talked
But
about
that was
ways that
being-
even without a union, it could be done.
Well, maybe, but
Yeah.
right. I have a different.
I'm not saying it's a good idea, but like it sounded like this was like, okay, like this is one way that so that we don't have to give positive or negative evidence to the vertical bar. Anyway, that finishes my thought to Jeff.
I just want. I'm a different way of thinking about the whole problem. Okay, just bop up a level here. So imagine we've learned these two models, and but now normally we would infer using multiple models at a time, like voting, right? So imagine I have a whole bunch of columns, and they're voting. Each column knows both of these models. Because all the components would be observed at once, there'd be more evidence for the eye than the bar, and you wouldn't have to move. The voting, you would decide right away, oh, this is an eye or this is a bar. So no movement's required in inference if you've got lots of columns going at once. Assume I have these two models in all these columns. Now we're introducing sort of an artificial system where we're looking through the straw, and we're moving around trying to observe the world. Of course, we know that this is actually very hard in reality to observe everything through the straw. But imagine I was doing that, and I move around and I see this eye. At that point, I don't think I'll question. Would I say, oh, this? I mean, I see the. Excuse me. I see the bar. I'm seeing the bar.
You see the bar, and then you see nothing.
Well, no, I haven't. No, I'm looking through a straw. So far, I'm on the bar. I'm moving around the bar. And I go,
Okay,
oh, this
so you
is
don't
the
know.
Bar. Right.
Yeah.
Now, do I sit there and go, hey, maybe there's another hypothesis that I haven't observed, is more to observe. I'm going to go look for that. I'm going to question that. I'm going to say, maybe not. I can come up with lots of situations where I give you some data and you think you understand it. And you say, yeah, I got it. I know what that is. And then I say, oh, but there's another piece over here I didn't show you. And then that changes everything. That now I have a different perception of what it is. So let me just walk through this thought experiment. It may not hold water, but let's walk through it. Somehow I've got these two models learned. I come out with my straw. I'm moving around and I see the bar and I go, good, damn, I'm done. I got a bar. I have no reason to look elsewhere. Now, I might be done, and I might miss the fact that it could be an eye. But in reality, in a real brain, a couple of things would be going on. One is, of course, I would have somebody observing the dot above it, and that person would know about the models, and that would make a difference. I would know it's an eye. If I didn't have that person observing it, it's like, well, I can't tell. I'll have to assume, if some part of the world is occluded and what I see is consistent with what I know, then I'm going to go with the hypothesis. I think that we might do that. Also, if the dot appeared, all of a sudden, I would say, oh, there's something up there. I have to move up there and attend to that location to see what it is, or something like that. But I'm wondering if this is the case where looking through the straw is not a good example, because it seems like voting.
It felt like when Niels was showing the example, it was pretty intuitive that, like, we're looking through a straw and we are able to recognize the bar. And if we have the task set up that it could be an eye or a bar, we would move to where the dot could be.
I don't know if I would. I'm questioning that. If I have no other context,
if someone told you that's what you had to know, that's what you're trying to figure out.
Well, but let's say, okay, I didn't know that. I'm just saying I'm a column, and if someone says you should be looking for an eye, well, then I would be evoking the eye model, and I know to look up there. But if I'm just asked to self, I'm looking at the straw and say, what is out here? What am I observing? Here's a bunch of features. They're all consistent with the model I have. And my straw hasn't gone anywhere else. Would I feel like I need to go anywhere else?
They're consistent with two models you have.
Yeah, but I might make the wrong assumption. I might just say, okay, it's a bar. Good, I'm done. I mean, that bar could be part of a picture of a banana. It could be part of a tank. I mean, I don't know. It could be anything. But at the moment, I've just asked, what am I observing? I found an object. Here it is. I'm good. I have no idea at this point. Is there anything else? I wouldn't even know to look elsewhere unless I had a different hypothesis. And the question is, why do I have a different hypothesis? I just bear with me on this. I think there's some validity to this.
I don't know. I mean,
Yeah.
doesn't it? It feels kind of like
with voting,
like the classic example of like a mug with a handle or without a handle. Like the whole idea is we'd move to where we think the handle is. Like the handle is just like the dot on the eye. We're trying to realize like what mug we're holding.
well, in this case, imagine if I'm moving my straw around the edge of the mug, I would see an area where there is a point where the handle comes in, and it's clear that this morphology is different. In this case of the eye, it's off in space, right? It's not.
Yeah, that's
attached.
deliberate because Tristan, you asked like, why aren't we doing the 1 versus 7? So that was deliberate because in that case, there's kind of this alternative signal for distinguishing them.
Is it an alternative signal? It's just that I get to the point where the morphology of one object doesn't fit anymore. Imagine I'm looking at the 1 and the 7, right? And I see I'm inferring, and I go, hey, I think this is a 1. Well, if I could observe the whole thing, it was consistent with 1, I'd be done. But if there's some other dot off to the side that makes it into something more than a 1, I'm not sure I'd go there. I mean, again, voting would work. Remember, voting would work. If you have multiple columns, it would reach the right conclusion. It's just if I'm providing impoverished input, where I'm only allowed to look through a straw, I'm questioning the fact that I would leave an object that I recognize to test a different hypothesis unless there was some reason to do so. Unless someone told me I had to do it, like unless the instruction was where you should be seeing a 7, or you should be seeing an eye, that kind of thing. This could be an artifact of 2 things. One is we got a single column, like a straw, looking through a straw, and B, we have discontinuous objects. And in that case, I'm arguing that the system will fail.
But it just feels like a human can do it.
A human does it because we vote.
So
No,
in the
but
case
with a
of
straw,
voting,
if I say, tell me whether you are seeing an eye or
right, that's a different thing.
a vertical bar, feel free to move as you need.
No, the human example would be, look through the straw and tell me what you see.
Yeah.
I mean, can it be both? Why can't we ask a human to do either?
You would settle on a hypothesis. Oh, I got it. I see what it is. Imagine it's the 2 theater faces. Like in the theater, there's like this. I don't know, there's a smiley face and a frowning face. You know what I'm talking about?
comedy and tragedy.
Yeah.
Yeah, right. Now imagine they were just like, 2 faces. But I'm looking through a straw and I see one face. And I go, oh, I got a face. I'm done. There's no reason to go anywhere else. I'm done. I got a face. It's all consistent. There it is. I recognize this object. I wouldn't go, hey, what other things might be out there? I wouldn't have thought of that. It just wouldn't occur to me that there's an alternate hypothesis that's different. It's like, no, I got an object. It's consistent. Everything's done. There's nothing wrong with this. It's a face. I got it.
So even if we vote, doesn't the problem still exist that if we're on the eye, if we're on the bar without the dot, then it wouldn't be voting, like the columns that are where the dot should be wouldn't be participating in voting. So all the columns that are voting have equal evidence for the bar and the eye, so they wouldn't be able to resolve it.
Well, but there is if I don't get it, maybe I'm missing it. If the dot is there, there's additional evidence.
If the dot is not there.
Dot's not there. It's the vertical bars.
So what's the problem if the dot's not there?
So if the dot is not there, then the columns that are observing the empty space where the dot wouldn't be participating in voting. So they wouldn't contribute any information about the absence of the dot.
Right, but that is consistent with being a bar. right?
So then the columns that are modeling the bar would need to learn about the absence of votes
No,
for
no,
the
because
eye.
the columns that everyone has models of both, and so the evidence, all the evidence sums up to saying it's a bar. There's no other evidence to
Yeah, but
suggest
there's the
otherwise.
same amount of
But-
evidence for the eye.
No, it's not, because
The same number of columns say it's an eye as the number of columns that say it's a vertical bar.
but the eye, they wouldn't, because the eye has this additional information on it, right? I don't get
No,
it.
it doesn't.
But yeah, and so they're all silent because there's nothing there.
Right. If there's nothing there, it's a bar. So I'm missing this. Maybe I'm sorry being dense about this.
But the columns don't know it's a bar. They have equal evidence for the bar and the eye.
I see.
It's basically one model is a subset of the other. And the missing parts from the subset, that information is not communicated anywhere because we don't communicate about things not being somewhere.
I think it's still going to work. Hang on.
I mean,
see your point,
yeah,
but
I guess
I
a
don't see
solution
it.
for this is maybe to modify
It,
voting somehow.
it
But
sounds like such a simple problem,
I know.
and we come back to it. Like this was I think the first item I put on the future work roadmap like 3 or 4 years ago because it seemed so simple. Yeah, let's send off object observations and use them.
I
But
think we're ready.
every time we come to it, there are some tricky things.
I'm still not convinced there's a problem
But
here.
okay, can I maybe just go through a few more slides for
Sure,
what I wanted to show, and then
Right.
at least then people can think about that. But I mean, I definitely take on board your point, Jeff. You know,
Yeah, I think I
how
agree
much
with-
do we consider the infinite space? Like, I like this example. I think this was from Chris Summerfield, but like, and this was a critique of Bayesian models. But it was like, if your doorbell rings, you don't think, oh, is that the Prime Minister of Finland with like a low probability? Like, you don't cover the like infinite hypothesis space that is possible. And so I take your point. Lacking further reason, would you really consider other hypotheses? But I still feel like there are conditions where you can say to a human, "This is the task," and a human can solve it. So, but anyways, maybe I'll just continue.
Again, the human being, separate a human looking through a straw versus a human looking with the full retina.
Yes, I mean through a straw.
Well, you know,
Yes.
here's yeah. Okay, go on.
And so, just Misha, if I just thought I'd answer your question briefly. So, yeah, I'm not sure if you were here at the start. So we are planning on like passing kind of a no feature observation, but one of the tricky things is we don't want to store that in the model because we don't want to store no feature. At least, yeah, and that's another thing I'll talk about later. Is like maybe how could we get a hybrid, but at least we don't want to store no feature kind of throughout all of space. And so so that's part of the trickiness of this. But
Yeah, makes sense.
cool. So then
I'm
yeah,
not
so
sure
anyways,
I'm not sure it means the process of no feature. Then, if you don't store it, what's the point of it? What is it?
yeah. Okay, well, anyways. So
Well, I think the point was like the very first slide that Niels showed, where we all agreed that if the hypothesis was that we should be sensing the mug, but we're not because we actually moved off of it, then that hypothesis was wrong and we should delete it. And that currently doesn't happen in Monty because if we move off the mug.
Start again. If I move off the mug, why would I delete the hypothesis of the mug?
Can you go to that slide again, Niels, maybe real quick? So
Yeah,
if
this
the
one.
hypothesis was that we should be on the mug after the movement, but actually we were off the mug.
Oh, right.
But this
Yeah,
is the
that's
straightforward condition.
That's the straightforward condition why we thought, oh yeah, we should add off-object observation. It's just a technicality that we haven't been using them at first. First time I wrote this down as a to-do, it was like, oh, this will be easy. Let's just process it and say, oh, this.
And then that was
this
actually
hypothesis
right.
was wrong. But then if we do actually sense that we were now off the mug or empty space, then we don't want that, like we don't want to be storing that in the model of the mug. And yeah, some of
But
these
the point,
other.
as soon as you move to the pink 2, the red 2, you'd eliminate the current hypothesis, right?
Yes,
Yeah,
exactly.
but right
So-
now in Monty we don't, because we don't send that observation to Monty, to the learning module.
Yeah.
It seems like,
Yeah.
why do you have to send an observation? Isn't just the fact that you didn't get one is sufficient? I mean, can't a
Well,
column
we
say,
also don't send the movement.
all right, now you confuse me. I'm a learning module. I'm in some location and I don't get any input. I'm predicting one. That's local knowledge. I don't need to send in a null hypothesis, right? It's just the fact I didn't get one is a null.
Yeah. I mean,
Yeah.
it's the same thing.
Okay.
Basically, we need to step the learning module.
It's just
Say,
you
okay, you have moved. You should have perceived something,
if
but
you didn't, then there's an error.
you predict something. But guess what? We're not giving you anything because nothing was perceived.
Right, but it's a local thing. It's really local. I didn't get
Yeah.
an input. I'm a bunch
Yeah.
of neurons. I didn't get an input. Therefore, it's not like the retina had to pass me a null hypothesis.
No.
Okay. All right.
Yeah.
That's-
In Monty, we kind of, I guess, need a data structure that at least tells the system this
Okay,
is a null
fine.
hypothesis. But yeah, I agree. In neurons, we wouldn't.
All
There
right.
wouldn't be anything passing.
Can
Right.
I
So
ask, can I ask,
yeah, please.
why is it that we don't send anything to the learning module in that case?
Because
In
on
that
object
case,
equals false.
we would want to because it seems straightforward, but it's all the complications it introduces. That's basically the issue. Like you're right. In that case, we should say you didn't observe anything, and it'll eliminate that hypothesis, and it'll be great.
So
Just like in general, I mean, like I recall, the sensor module processes the observation. It tries to extract features. I guess there aren't features to extract because we're looking at the void. Decides not to send anything out, right?
Yeah, the use state variable, this is very code-like, so I think the use state variable is if the on object is false, then I think the use state will be false even if we extract other things.
yeah, there are several reasons
Yeah,
why we don't send
there's-
observations to Monty. For example, also if the features haven't changed significantly, we wouldn't send it to a learning module. But I think, yeah, this is the kind of clearer part of what we definitely want to keep on the roadmap, that
Yeah,
we want to send
So,
that
yeah.
to we want to at least send a movement to the learning module. And even if we don't have any features, sense that at location, not even an orientation, not even a morphological feature. We still want to send the location
Do
chain
something.
and then
yeah,
use that.
yeah.
Right. I
And
think
that could be a way to tell, like, if there's no feature sent, just a location, don't incorporate that in your model.
Right.
Yeah,
Exactly. But yeah, and I guess at a practical level, Scott, I guess part of the issue is it just will change a lot of things. But you're right, it is a change we should make, that one at least. But like, yeah, we want to make sure it doesn't we don't store these during learning. So yeah, but there's ways we can handle that. But also logging tends to make or like the buffer tends to make use of off object observations to like filter and stuff. So it's the kind of thing that unfortunately once we change, there'll be some like knock-on effects. But yeah, maybe I'll quickly just
I'm
try
not
and
following. I didn't follow any of that. I think that's all.
yeah, I mean
That's
some of
okay.
that's kind of more
It's a code thing.
practical.
Yeah.
Yeah.
It's not really. So for a suggested approach, to kind of rephrase what we kind of want, what I'm suggesting we want the kind of learning module to be doing is, so you've moved up here to this location. You're no longer looking at the vertical bar. We're just going to have that representation go quiet. And I'll suggest what that means at a neurological, like a neurobiology level in a minute. But then the representation for an eye is actually going to get negative evidence. And I think what's nice about this is, as well as potentially helping with some of this, it has kind of a natural kind of biological analog. So for the representation that goes quiet, this is the out of model movement. Dendritic spikes which are kind of generally associated with predictions, are known to have these much longer time constants that they maintain the membrane potential at versus spikes at the soma and the axon. And so what this could practically mean in Monty is basically the evidence level stays the same or is like slowly decaying when we move out of the model. And what that means is that if we move back onto the object shortly after, like let's say we go up, oh, there's no dot, we move back down, the evidence will kind of continue to grow and maintain its level. But if you remember the eye, it's going to get negative evidence because there was an actual prediction error. And so that would separate the hypotheses and actually enable us to say, oh, it's a vertical bar. And yeah, and it's also worth pointing out that from a biological perspective, like a dendritic spike, it can maintain the membrane potential at this elevated kind of level without necessarily initiating a spike, which means, that satisfies this kind of property of going quiet, in that when you move out of the model, we don't want those cells to be telling, that column to be telling other columns, oh, this object is still here. So we would be kind of primed to still expect that object, but it wouldn't be telling other columns, yeah, this object is here.
I think that sounds right.
Yeah.
Good observation. I'm having trouble relating that to the overall big problem, but I think this is a mechanism by which you could maintain a hypothesis that's not actively doing anything. I think that's what you're saying, right? The cells will be primed by the previous hypothesis, and so when you go back, it's not like completely forgotten.
Right, exactly. And like we've talked about how part of that will be from top-down feedback. Like certainly over longer time scales, if I'm walking around my room and I turn around, it's going to be top-down feedback that is telling me to, you know, expect the table or whatever. But this is kind of more at a, I guess it could be at like a cellular level over very short time scales as your eyes are just darting around.
Right. Well, I'm not sure I agree with the second thing you just said, like a top-down feedback. I mean, again, we're trying to differentiate between like I'm trying to infer an object and I'm not sure what it is, or I have a model and I want to make predictions from the model. You know, when I come back to the room, that's like, oh, I have a model. I'm just trying to remember where things were, and therefore, you know, I'm making predictions. But it's not like we're trying to understand how we infer the dot from the eye or the eye.
Yeah. I'm just talking generally. Anyway, maybe that's a distraction. I think that's a point we agree on. So maybe it was just the way I worded it.
Right.
Yeah, I think it's just because we considered that as a possible alternative to the going silent. That instead, the hippocampus could be building a very quick temporal map that here used to be the vertical bar. Now I moved off. Now I moved back on. So re-invoke the vertical bar representation.
Yeah, maybe.
But at least when we thought about it, it didn't feel like a good solution. So
yeah, especially because we didn't know yet that it was the vertical bar. We thought it could be the eye.
Right.
I want to go back. Sorry, I have to repeat these things over and over in my head sometimes. I want to go back to what I thought was a critical observation, or at least I'm arguing it's a critical observation. That if I'm thinking about a single column inferring an object, I'm going to be following the edges of the object. That's what I do. There's nothing, that's all the information. There's no information in the middle of the object. There's no information outside the object. I'm following the edges of the object or the features of the object, which are just continuities of some sort. And I'm going to move continuously, say, around this object. Because I have no other reason to move off the edges. I'm just doing a model-free movement around this thing. And if I come up with a hypothesis that's consistent with all the data, and I can move here, and then I can use hypothesis-driven predictions, I'm not going to search for another model. I'm not going to search. So if I find the bar, I'm not going to search for the eye. I'm done. That bar could be part of lots of things, but I'm done. I've got something that's consistent with my data. If maybe that dot's off somewhere in space, someplace. I don't know. Why do I know to look for it? And so I have an answer. It's not like my data is inconsistent because there could be other answers. I think that the answer here is that it's going to settle on the bar. That's it.
Kind of.
And obviously, if the dot is close enough to the bar so that as I'm going around the edges of it, I detect the dot, sure, then I have some more data. But if the dot's further enough removed,
Well,
then
what if you're looking at like a line drawing of an airplane or something, or like a smiley face, and like you're not going to explore the internals of that at all, or
well, again, we're talking about the straw example,
yeah,
right? Right. I think in the straw examples, I would, if I explore the internal space, I might say, oh, it's a circle. I found it. I'm following its edge. It's a circle. I'm good. And maybe the nose and the mouth and the eyes are small features in the middle of this big circle. I wouldn't know to look there. I wouldn't
You
say,
don't
oh, it
want
could.
to explore the rest of the
Well, you
picture?
might, but
I feel like
not,
if you had the hypotheses,
but it's like you said with the prime minister at the door, right? I have a solution.
Right.
I
agree
haven't
with Jeff.
I haven't come across any evidence against the solution. All the evidence I have is consistent with my solution. I'm done. Otherwise,
okay, I think the example or like what we're considering is essentially it's almost like you have the goal state, which is determine whether this is the eye
It's a
or the
different
bar.
task.
That's a different
Yeah.
task,
Fine.
right? That's a different
Fine.
task. So let's
But
talk about.
you still need a way to solve it.
Okay, all right. Well, let's just go there now. Before I go to that, let's go to the separate test. Vivian brought up the issue. I said, hey, if we have voting among many columns, we would immediately determine the eye or a bar. And I assume that's the case, but maybe that's a problem. I think, Vivian, you said you don't think that's going to work. So I don't know. But I'm assuming that's going to work. So now, so if I have lots of voting, columns voting, I'll get my right answer. If I don't have lots of columns voting, and I only have a little straw, I will settle on the first hypothesis that is consistent completely. Now, there's a separate question: is I'm told to look for the eye, or is there an eye here? And then at that point, I would invoke the eye model. I would say, oh, this is consistent with the eye model. This is consistent with the eye model, and I would suspect the dot appears consistent with the eye model. But I wouldn't just stumble across it. I'd have to
But it's remember in this case it's a vertical bar.
So,
well, okay, so
would you have some representation of which model is the simplest explanation? Like, would they have associated complexity with them, and you go with the simplest one, or would you?
I would say
see
again,
about when you
we're talking about
them?
we're talking about the straw,
Yeah.
and if I was not given any other priors, and just says, what are you observing out here? I would in some sense I would stop at the moment that all my observations are consistent with a single object, and I haven't discovered anything else by tracing the lines of this object, tracing the features of this object.
But they're also all consistent with the eye.
Right. But again, with the straw example, I can't know that. Maybe it's like
I think actually
I'm going to go with the simplest one, right? The one that solves the problem. I'm going to reach my conclusion. Maybe there's additional evidence in the world that would change my conclusion. This is a general truth of life. But if all the evidence I have right now is consistent with the conclusion and it's not partial, it's all there, it's consistent, I'm going to go with that hypothesis.
So now, you have a representation of how simple the explanation is. So you go with the simplest explanation.
No, it's simplest. No, I go with the first thing that's completely consistent with the data I have. And the data
so are you tracking when you have how much of the model you have covered?
When the bar example, I've observed the entire bar. There's no pieces missing. It's all there. I'm done. It's not like, oh, I have a partial bar. I need to keep looking. We said, oh, I've explored the whole thing. It's there. I got a bar. There's no question. There's a bar. It is a bar.
So you kept track of if you have covered the entire object.
I don't know if I have to keep track of it. It's just like at some point you have enough data to say, this is consistent. Everything I've done here, I can make some predictions. I don't know. I mean, when do you stop looking? I don't know the answer to that question, but
I mean, I'm just asking so many follow-up questions because if we do go with that premise, we have to redesign all of our experiments going forward because we can't do straw world experiments anymore. We can't do experiments with one learning module anymore. Like once we have a more complex environment.
No, you can. I'm sorry. Go ahead. You want to say something, RJ?
And so I think so. In Monty, we are naturally driven by one task, which is recognition. So, like so when when the task is just describe what you see, I think bar is right. And if the task is what could this be, then it will say bar or I because it knows both bar and I model. And then if the task is what is this, then at least Monty will it has motivation to explore because it wants to narrow down to one hypothesis only. Like even if it explores and sees only the bar, we force Monty to explore for a minimum number of steps. Like,
Well, it's
or
more
there's
like it's more like if you take the Yale data set and
yeah,
you're saying, okay, these are known hypotheses. We need to determine between these. That's additional
yeah,
information that you don't always get in the world, right?
right,
No
I
right.
think maybe it would be helpful to clarify, like, I feel like what you're discussing is more the policy, but the point that I was originally trying to raise is that even with the policy that moves you to where the dot is going to be, Monty currently cannot distinguish the hypotheses. That's the issue. And
Well,
Yeah,
at
so
least
that part we need to
maintaining this
update.
hypothesis
Yeah.
but maintaining the one even when we move out of the model and negating the one that fails to that incorrectly predicts that it should perceive something. That should help with that situation.
all
But
right. So I think now we're getting down to some very important, like implementation details, which are maybe not as conceptual as they sound. I mean, it seems like all the information is there.
Yeah, we still need to update so that we do the first case that you showed, like where we need to eliminate the hypothesis if we're off the object, but the hypothesis thinks that we're still there.
So maybe think of it this way. Let's say a learning module will behave the way I just described. It'll say, I'm going to reach the first, I'm going to reach a conclusion. When I have enough data that is completely consistent with one of my models and there's no contrary evidence, I'm done. And so it wouldn't recognize if the dot's too far away and it didn't see the dot, then it wouldn't think about the eye. However, if we want to impose some other things like this is what you should be looking for, or these are one of the 70 things you should be looking for, or let's go through these in order. Is it this? Is it this? Is it this? Then you have all this extra information, which every time you do that, the column will invoke a different model and say, okay, well, all right, I have a new model. I can make predictions based on that new model. And is the data consistent with it? And do I make further predictions like, oh, it could be an eye. Well, let me see if it's an eye. I didn't consider that because I didn't have any evidence for it, but you want me to look for it. Now I'm invoking the eye model. I will go look for the dot. And so the learning module could itself be pretty dumb. It doesn't have to search through all the hypothesis spaces. It's just going to search until it finds one that works and then says, I'm finished.
And maybe that is what happens. But then I agree with Vivian that then we almost need some sense of like model simplicity, because what is special about the vertical bar? Why is that privileged in some sense over the eye? Because again, in existing Monty, they would both have equal evidence at that point.
Yeah, James said completely consistent with the model, which I think to me it means that basically how much we've covered of the model. Like we'll be adding evidence proportional to how far we are in exploring that model we have saved. So it's like if we're at the end and we know like we've covered 90% of the bar, then we'd be adding more evidence than if we've covered 70 or 80% of the eye because there's a dot.
Yeah, I don't like this idea. I don't like the idea that we have some sort of tally. It's more like it doesn't even consider the eye once it's settled on the bar.
Just pick one randomly. Do we have to be deterministic about it?
Good. Right. It could. That's an interesting point. If it just said, okay, I'm going to pick a hypothesis, and if it works, good, I'm done. I'm not going to look any further. So if I randomly pick the eye, then I look for the dot, and if it's there, I'm done. If it's not there, I eliminate that. And if I pick the bar and I see all the bar information, I say I'm done. I don't look for the eye because I didn't. It could have been a random choice to begin with. Yeah, could have been. Again, just imagine you're looking through the straw, and when you're looking through the straw, you have no idea about anything else in the world other than what's in your little bit view. So it doesn't look, you're just following this line around until you find out, till you recognize it. And there's a ton of other stuff that could be going on in the world, but you just can't deal with all of it, right? It's just deal with what you got. Again, this is a very strained example because we're doing the straw example. In reality, it wouldn't happen that way. In reality, you'd be voting, and I think voting would solve all these problems. But in the straw case, I think that's what it would do. You could pick a random hypothesis. I mean, a random one and follow it to its completion, or a random model and follow it to its completion. And when if it's all consistent and there's no alternate evidence, you're done. And so I wouldn't think to look for the dot.
Yeah, I mean, I agree. You wouldn't in reality, you don't spend forever on every object trying to cover all of it until you move on to the next thing you want to do. You get reasonable amount of evidence and you move on, you have other things to do, kind of thing. But yeah, I feel like besides how the policy would be and how efficient it would be and all that, I think the general issue still exists, and the general thing is still that we want to process the observation. Like if we expected it to be an eye, like Tristan wrote, like if it was in a word and we expected an eye there to be there and we moved up and the dot wasn't there, we still want to be able to deal with that case.
So and why wouldn't we be able to deal with that case? Why wouldn't we notice that the dot's not there, and then we have a problem? Why wouldn't? What's the problem then? If we don't see an expected feature.
Well, we would have to make the changes, I guess, that we discussed today, but maybe there's no controversy about that. And
yeah, I think the changes.
And I think we've kind of settled on maybe a reasonable approach. I guess there are some edge cases, quite literally. We don't necessarily need to go through them together, but maybe there's time.
Yeah. So I guess just to recap, the necessary changes are in Monty to first of all send the observation to the learning module, which we currently don't do, and second, in the learning module, to process that observation in a way that if the model predicted to see something there, but it didn't, it gets negative evidence. If it didn't predict to see something there because it's an out of model movement, to silence that hypothesis and keep it for a short amount of time so you can get back to it when you move back, like the next step.
Yeah.
Does everyone kind of agree with that?
I just saw you at the critical moment there. My phone decides just to switch my audio to something else. I'm sorry. Can we back up a little bit? Maybe not.
Maybe I think we all just agreed, so that's just
okay. Right.
Yeah, good idea. Let's keep going.
Sorry.
Well, I have a question.
This is your way.
Where did you lose it?
About, I don't know, 10 seconds ago. This is your way of silencing me. You have a button that you push it. Just silence just sound. Sorry. Who was that? Tristan who just spoke? I forgot. I didn't hear.
Real was Robbie.
Will.
Oh, Robbie.
Robbie. I'm sorry, Robbie.
Well, I forgot. I'll ask it.
But yeah, do you want me to repeat something, Jeff?
I think there's no harm in saying it again.
Yeah, just
said
say
it nicely.
Again.
Okay, so I'll just start at the beginning. So the two changes we would make to Monty is one, to send the off-object so the no feature observation to the learning module when the dot is not there. And two, to process that observation. And the way we would process it is if the model predicted to send something there, like the model of the eye predicted there should be a dot, it doesn't get something, it gets negative evidence. If the model didn't predict anything because it was an out of model movement, the model doesn't store any feature at that location, then we silence that hypothesis and keep it for a short amount of time so we can get back to it if we move back onto the bar in the next step.
Yeah, it's sort of like saying, what if I had an answer to the problem? I've inferred something, and I just decide to go someplace else and test another hypothesis. I don't want to forget my first hypothesis, which is correct. It's like, oh, it looks like a bar, but you want me to see if it's an eye. I'm gonna go see if it's an eye. No, it's not an eye, but don't forget, I was still thinking it was a bar.
Yeah.
Yeah,
I didn't get any evidence against it.
Right, it's sort of hysteresis sort of effect.
Yeah.
Right.
Yeah.
Yeah, that's you have to do that. It's like you don't want to forget everything just because you know, once you get older, it feels like you do this sometimes. Like, you know, you're in the middle of something and then, you know, the door opens, you look over there and you come back and you go, oh, well, what were we talking about? I can't remember what we were talking about. Or Dory the fish in Finding Nemo, right? That's what she does. She gets distracted and has no idea what she was just thinking about.
Right.
So we don't want that to happen. Right.
So yeah, so I think actually, Vivian, I won't go through the literal edge case. I call it the literal edge case because it's a scenario where if you're near the edge of an object, weird stuff happens. But basically, I think as long as we're doing this clamping of the out of model movements, it's not an issue. I guess the only thing is in our standard Monty, one of the main ways we eliminate hypotheses isn't, we don't call them out of model, but just when we have a location hypothesis that's far from the existing ones, it gets negative evidence. So I guess
say that again.
But those are when they predict to sense something, right?
is it only then? Yeah. Okay.
So, well, in those cases, they would predict to sense nothing because they're far away from the model, but you do get an input. And so this is a prediction error.
You know, you have to be careful too, because if you go beyond your current hypothesis and it's some other space, just randomly, you might find something there.
That's
right?
what I mean. Yeah, because often there will be something there. Like I know up until now we've been talking about empty space, but actually in a lot of environments there's just something there.
I think the key things here is like under hypothesis A, if a column is observing outside of hypothesis A, whether it moved there or it's just a different part of the retina, we should ignore its input. Just ignore it, even if it's some input. It does. If I'm outside of hypothesis A, it's irrelevant over there. It could be another object. It could be something else in the world. If my object A makes a prediction about something in some place, and I go there, it should be exactly the right prediction. It should be that feature that should be there that I'm observing, and that would be consistent. But if it was a different feature, then there would be negative evidence.
Yeah.
Then
it's more radical thing where we basically say any kind of out of model movement, like any movement beyond, like nowhere near stored locations, we just kind of, I think clamp is maybe the wrong word for the evidence. I think what we want is it to slowly decay as long as we're out of the model, kind of like in the EMA neurons that Rami was working.
I'm still thinking about, like, when a bunch of columns are voting, a lot of them are going to be off the model at any point in time. But if they're voting, they all have the same hypothesis maintained in layer one. They're all, the voting neurons are still voting, just because I'm, it's like I'm a column. I know we're all looking for, we think it's object A because that's coming in on my layer one neuron, so that's the voting hypothesis. But I'm out of object. I'm off someplace else, so my input doesn't really matter at this point in time. But I still know what everyone thinks it is. And if I become within object, if some reason I move and now I'm within object, well, now I can make a prediction. Remember, in a real scenario, most of the columns will be moving around together, and most of them will be off the object at any point in time. And the hypothesis, I think, would be maintained by the voting neurons.
Yeah, so that could help kind of stabilize it.
I think that would stabilize it. That is persistent.
Yeah, maybe with the final time that's remaining, I'll just talk a bit more about this kind of color filling in thing, and I'll just. So I think we have an action plan. I think we have something we can implement. We don't need to change the policies. Agree, I think we actually agree on that, but I think we also agree we need to make some changes, some minimal changes for Monty to work a bit better. But the question is, can we do more? So should out of model, movements, which, provide positive evidence? Does this mean storing some concept of kind of empty space? But what if you move on to another object? Of course, you can't then predict something in that case. And just to kind of, try and motivate this, imagine how you represent an empty room. That's very different from an unexplored room. You really do seem to have some concept of this emptiness when it comes to kind of motor planning and things like that.
But why is it, isn't empty just like at this point in the reference frame, there's no object expected?
But in the current
Yes.
implementation, the current thinking is equivalent to you have never looked at that location.
Fine, but maybe I don't know the difference.
Like in this case, you have looked there and you know nothing is there, versus you don't know what's there because you're not storing anything at that location.
Yeah.
Or maybe another example is like the concept that an object is solid, that this space out, beyond the object is empty, but if I was trying to kind of predict what I would feel inside the object, like I know there's some solidity to it.
Well, I guess I don't see this as a very. I don't look at. I'm just not jiving with this particular problem here.
Okay. Maybe another example is just like what we kind of predict when we're looking at 2D objects.
Can I just go back to the room, for example?
Yeah.
The room is not a cube. The room is a set of walls, and you've explored those walls, and there's space outside the walls and there's space inside the walls, and I'm not sure there's much of a difference between those two. It's just a set of. It's not like it's a cube and there's the inside and it's just like there's these edges and these walls and they go around, and so I'm not sure the inside treated any differently than the outside. Even if I haven't explored all the region around the outside, it's not important. I haven't explored all the places on the inside, it's not that important. I just, as long as I've explored enough of the walls. Now, obviously, in a situation like this, we look at the entire room, and our retina can quickly scan over all parts of it, and we don't see anything that's inconsistent with a wall, and a ceiling. Nothing is blocking those things.
Yeah, I mean, essentially, like the objects in the room is actually maybe what we just discussed solves this, because objects in the room are kind of like the dot on the eye. Right. So in this case, there are no objects in the room. So the hypothesis for crowded room is going to receive negative evidence. The hypothesis for empty room is going to be stable and basically win just through.
But it gets complicated in a situation like this where vision looking at the whole room, because in some sense the dot never occludes the bar, but a chair in the room might occlude the window. And so it's hard to come up with something in the room that doesn't interact with any other part, that doesn't occlude any other part of the room, right? So it'd be difficult and we're looking at a distance. We're not feeling our finger along the way. If I was a blind person, I was in the room, I was walking along feeling the finger, and I go all the way around it. Yeah, I would have no idea there's a chair in the middle of the room. But from vision point of view, it's very hard to miss it because it would occlude something. I can't observe the wall without seeing there's a chair edge, so I'd have to deal with it. But if I'm just touching it, then the inside and the outside of the room are all the same.
Yeah.
And I don't need to. I guess I'm saying there's no reason to encode. There's nothing there in the room, just like you don't have to encode other things that are not outside the room. It's the room.
Well,
the room is the walls.
If I'm gonna, I just want to skip ahead in the last 5 minutes just to. Because it ties into what we started with, which was this kind of filling in. Because, and I think we've talked about this at some point before.
Well, by the way, we didn't solve the filling in problem at all, right? We didn't really.
Right. But whether if morphological features kind of have a concept of a sort of directional prediction.
Yes.
And
Oh,
so
wait,
and this
wait,
could,
prediction or directional an orientation?
so an orientation, but that's also providing a prediction about what you would sense. So
Oh,
that could be
no, the orientation says I would, it's part of the feature. So if I go to there, I expect that feature.
maybe it'll be clear in the next slide. But so
Okay.
just imagine that we want something that basically a representation that will help us predict, okay, this is empty space, or in the other direction, oh, I'm expecting white, and I'm expecting white anywhere. Like I don't want to store white at all these points. So it's going to be a particular color, a particular texture, empty space, solid space. And it feels like with a fairly simple and kind of biologically plausible kind of spreading function, when you sense a point, this could kind of spread until I'll show it in an image. It's clear. So okay, you're sensing here. You want to know whether that's empty space or solid space, and basically this kind of ring goes out, and then the first thing it touches is this point. And if each point has kind of, oh, in this direction, I've stored, when I was sensing it, there was empty space beyond it, and I'm presumably solid below. So it's actually stored. So this location, I'm going to assume, is empty. And this kind of, hopefully it's clear how this kind of relates to the color filling in thing, that like, if this was a red edge, like red on this side and blue on this side, and I'm sensing here, basically I spread out and I see, oh, okay, in my stored model, the nearest thing is this edge that's red on this side. So I'm going to assume I'm seeing red.
Can I just push back a little bit on this? I mean, I think the general ideas seem pretty good, but I don't think we should be storing anything off the object and saying there's nothing there. That's not part
We're
of the
not
object.
storing anything off the object. It's stored at this point on the boundary.
I guess all I would say is like, it seems more like the following, because obviously the golf ball is the object, and the stuff in the background could be trees and dogs,
right?
And, mugs.
I guess in this case, I'm assuming a finger is moving here, so it's hovering above.
Okay. I don't even know what to make of that. Can we stick with it? We got a picture here. Can I think about vision for a moment?
Sure. Okay. If we're saying it's color, if we're saying color, and then I've learned that golf balls, I guess, yeah, it does. Yeah. Okay.
I mean, imagine you just have a circle. It's not a line, it's a solid circle, right? So, I mean, we could do a line circle. That would just be a bunch of features at locations around this, and now we're done. Now we're saying, oh, the edge of the line is not really a line, it's a color boundary. The first question I ask is, well, how do we know that the white is inside the color boundary? Why is the white part of the object and the other part of not? How do we know that where the object is and where the world is?
Right.
I don't know the answer to that question, but let's assume you have some idea of closure here. So how do you? I think what's right is to say at the boundary, you have this transition where you have a color boundary. And the idea that you just assume that all things in the other direction are continuous at that same color.
Exactly.
But I don't.
And you haven't come across any other learn points. Obviously, if you had another learn point here, then you would rely on that one to tell you what to expect.
But I don't. In this case, I don't think I'm going to predict anything about the golf ball because I don't know on the outside of the golf ball because I don't know what's there. I mean, it could be grass, it could be the carpet. Who knows?
I guess that's yeah. Yeah, that's fair. I guess just the proposal was maybe this would help with the empty thing, but maybe it's more appropriate for just doing like color and texture.
Well, it's an interesting question. How does it know that at this point on the object that one direction is the world and the other direction is the golf ball?
Right, and then you could do something kind of similar for.
Well, I guess one thing is to say you have this. Imagine your edge. Your edge is now a color edge, right? White on one side and something else on the other side. And everywhere on the object, you have the same white transition. And imagine there's no any features inside. In this case, you see the dimples and you see a bunch of stuff. So, but imagine it was just a pure white disc.
Yeah.
Then essentially the idea is that you just keep going until you get to the next edge and you assume it's all the same, right? You just keep going across. What I'm struggling with, this is almost a slightly metaphysical question. is there a neural representation for the white in the middle of the golf ball? Are there actual neurons that are firing representing that white in the middle of the golf ball? It's a perception that it's there, but there's a lot of things we perceive that are not really correlated directly to neural firing. It's like, an axon could put a spike and you feel it's pain. Another axon is a spike and it's a color transition. So,
well, yeah, it feels kind of like the location representation that's active would be here, like this location in the reference frame, but the feature prediction that's active, it's kind of deferring to
right
to this, and so in that sense, kind of white neurons are active.
But are they? I mean, I don't know, because is there a feature there? We have these color blobs in the cortex, and maybe color in these sort of things are really some special mechanism for doing this. You know what I'm saying? Well, I think the general idea that, as you just said, is probably right. You have to absorb the feature from the nearest boundary, or from the nearest point where you have the nearest feature from some other near feature. It's like, because there's no feature here. But why how is it we perceive that? I have no idea. I mean, I don't know what the hell that means.
But yeah, I mean, what's nice about this is it'd be relatively straightforward to implement in Monty. I think even Vivian at a retreat a while ago, we discussed an idea around similar to this with as a way to basically have sparser models.
What do we do?
Then for surfaces, we could just store a few nodes, and then you rely for all features on just your kind of whatever your
So
to a certain
this is something
degree,
I've been thinking about.
Oh, sorry. Just quickly. So we have a bit of that already. One is in our distance measure. We look further for neighbors along the surface, like in the direction of the curvatures. Then we look away from the surface, so in the direction of the point normal. We don't look that far in that direction when we look at nearest neighbors. And the other one is kind of the direction in which the surface normal points tells you in which direction the space should be and in which direction the object should be. So,
but we're just assuming by basing on the curvature,
the
surface normal. The surface normal.
All right.
The surface normal always points out of the surface. And so one of the issues I kind of try to deal with pretty early on in the project is thin objects. So I guess if at the most extreme, think about a sheet of paper, and one side of it is red and the other side of it is blue. And if you're sensing a blue point, you know immediately which side of the paper you're on. But in Monty, if you're just looking at what's the nearest point in the model, the red points are very, very close to the blue points. And so what we do in Monty is, I think at least we still do this, is to look at the surface normal and only look at the points that have surface normals that are in the same direction as the one we're currently sensing. So we would just not consider the red ones because their surface normals point opposite of what we're sensing.
Yeah.
Yeah, so that's about as much of concept of surface as Monty currently has.
Yeah, it's interesting. It's like I've asked myself a question like this: do you perceive the color of the surface of an object as its neural representations, or do you have to go and ask? It's like I could ask the system. I could say, "What is the color at this point?" And then say, "Okay, let me calculate it." Right? I calculate by looking out and finding the transition points and then extrapolating from there. That's a different system than one that is representing red everywhere. It'd be more like, okay, I can ask the question, what is the color here? And then you can answer it. I'm looking around the room here and it's not clear which of those is the right one. It's like, it's hard to separate the fact that I'm trying to ask what is the color from what do I perceive if I didn't ask what the color is.
Yeah, because as soon as you attend to something, it's kind of like you're asking.
Right.
It's like, what do you perceive without attention? And you can't even do it by trying to use memory because it's like, okay, well, now you're attending to a memory.
It reminds me of, I grew up in the age of black and white TV. And when I was a kid, we had a black and white television. And then we got a color television, which we had both. We had a color television, black and white television. And I was struck by the fact that when you watch the black and white television, you have absolutely no idea that anything's different. Once you're in it and you're watching it, you never ask yourself, where's the color? What color was that? It just seems totally normal. There's absolutely nothing you didn't understand. It's all completely normal. Of course, we have to do this when we see things in the dark. We lose all of our color sensation. If it's dim light, you lose color sensation. We're not even aware of it. We just don't know that color's no longer there. So it makes me wonder, like, is color something I can ask about and then give you the answer to, as opposed to something I perceive?
I think it's definitely perceive, because we have blind spots. We're constantly missing color at some spatial thing, but
right.
like,
But my point is,
yeah.
what I'm saying, Jose, is there's maybe no neural representation at all.
Yeah.
In the middle of a red object, until you ask the question, what is the color in the middle of it? Then you can calculate it. Then you can go, oh, okay, what's the nearest thing, and bring it over, as opposed to it's a neural representation there all the time.
Yeah.
I feel like the vision in dark is a good example. Like if I'm looking for a t-shirt in the dark or whatever, initially I'm just like, yeah, my vision's normal or whatever. And then then it's like, hang on, these all like I can't actually pick out the green shirt. It's impossible.
Right. In dim light, you lose.
Or like
color.
I think I pick up the green shirt. Like it's kind of consistent with my expectation.
Right.
But then I realize actually, yeah, I can't tell.
Right. So those examples would suggest, they don't prove it, but they suggest that color is this extra piece that you just don't even. Color transitions we get, right? Those are represented on the edges of objects. Those are there. But surface color or large areas of monotone illumination may not be represented, and they're just like, you can ask them and say, oh yeah, they're I can tell you what it is. I can ask the question and get the answer. I don't know
what would happen if you would close your eyes and then you put on like glasses that are only one color. There's some kind of light source under your eyes, and then you open your eyes. There are no edges. You just see one color. Would you know what color it is?
Probably maybe related to Tristan's blinking thing. Maybe from the transition from no light to
when
this
I
light,
put on like
probably
red
would.
tinted glasses, everything looks kind of red, and the only way that I could infer that it was a different color was because the color of the object is interacting with the redness. So I know that it's like a darker red, and therefore
I do know that let's say if you could only see the world in one color, let's say you're watching a black and white TV, but it was blue and white. It was blue and white, right? Well, even then, no, you have to go. I do know, as I said earlier, if you're just in a saturated color, it's all you can see is a saturated color. Your sense of color goes away. You kind of lose. You just don't know.
But like there's like lithium lights, I think, or some sort of thing like that, where it's pure yellow, and it's it's a single frequency as well.
Yeah.
And so you can see perfectly fine, but basically the only color you see is yellow, and you can. I've spent a long time in a room with that, and
but
it's not like your perception of yellow goes away.
But you have it's yellow because you can still look at something else that's not lit by that light. Like if you're
no. Well, no, I mean, things are either like I guess a shade of gray or whatever, or yellow.
All the light is that sodium light. Yeah. That's it. Interesting. Do you? I wonder, do you lose the perception of yellow at some point? It's like
no, I mean, because it's this Icelandic artist. He's famous for doing it, but I think they also used it in like before green screens. They could do some clever like filtering.
No, I'm talking about. You put me in a room where there's no other light except for sodium light. That's the only thing that generates light.
Exactly, but that's exactly what this Icelandic guy does. He fills rooms at like
museums. But once and I can't see anything else. Would I always after I'm in there?
So you see people, and so maybe it's clear if I send a screenshot of what it looks like.
They're lit by the lithium light. Right. But the lithium light could change color when it reflects off of something.
Yeah. So like you see, it essentially looks like this. So you see like shades of yellow that border on black, I guess.
I guess I was wondering if I spent enough time in this room, would I would the yellowness disappear? Would I no longer know that it's yellow?
I at least didn't experience that, and
Yeah.
I remember I stayed in for a while.
Yeah.
This one was really cool. I'm sad I didn't go to this one, but
What was it like when you left? When you left the room?
I don't honestly, I don't remember anything unusual. Like, say for example, when you're running on a treadmill and you step off and you have that sense of like moving forward, or you step onto an escalator that's broken and you have that like jarring. I don't remember anything like similar in terms of color perception. But maybe I wasn't paying enough attention.
I have to read, just you're always chatting as opposed to speaking, but go ahead. He said, do we have detectors of cones? You're right. We do have, the cones do detect specific colors, or sort of. I guess what happens in the dim light is the cones don't work at all. That's the problem. That's why you lose color. When the dim light, the cones, they just don't work.
And I thought the reason you lose the color perception if you see only one color a lot is that the cones fatigue. So that's why you see the after images after you look at like a very bright red circle and you look at a white wall.
Right. Yeah. All right. Let's maybe it's a little bit off topic, but I think we have a hypothesis perhaps that at least I've thrown out a hypothesis that the color across the uniform surface of an object is not actually represented at the locations, but if you go to the locations and say what is the color here, the system has a way of extrapolating at that moment from boundaries.
But yeah,
like that.
I think there would be complications, I guess, because then it's like, okay, any point in a model is now considered making a prediction.
Well, no, I'm saying it's not. It's not part of the model. My point is that the interior of there's no representation of the inside of a blue circle. It's just if you go there, you can.
I guess maybe what I mean is, maybe with color it's fine actually. It's more about the off surface thing. It brings in that whole off object thing again.
Okay, well maybe I was just trying to. I thought you brought back color, and I thought we could just put it away.
Okay, color is definitely simpler. So
I don't know. So
should I do a summary? And
do we feel like we've reached any kind of?
I think so.
I think we have an action plan. At least.
We have an action plan for off object observations. I think you've made some good points about kind of policies and how we think about that, I guess, in terms of exploring hypothesis spaces. And then we talked briefly about this kind of color filling in and also at the start.
I just think that you had a specific problem you were trying to address, and the question is, do you feel like we've made enough progress?
I think, and I think when Vivian and I were talking about it yesterday, we already thought that okay, maybe we now understand it. I think the thing is we've revisited so many times that it felt like until it was discussed more broadly, and also with you, I didn't feel confident saying okay, we have. But now I do feel confident that we can update this task.
Okay.
And so that the person in the community who's interested in working on it, Carter, he can hopefully get started.
Right.
I'm worried now that the problem you brought up towards the end is a problem where now how do we deal with if the hypothesis is too far out of the reference frame where we currently just delete it, but probably
let's talk about that one offline. I think I think it's solvable because it'll just mean anyways. I mean, worst case, we have the fallback of just saying a human won't go there, and so Monty doesn't have to go there.